Hi everyone, welcome to North Campus Essential Calculus Problem Series. In this series, we solve important calculus problems step by step, making sure every concept is clear and easy to follow. And in this lecture, we will solve the integral of tangent to the power of 5x. Do not forget to subscribe to the channel and leave a comment if you have any questions or suggestions. Okay, let's write the integral again. Integral of tangent to the power of 5x dx. To evaluate this integral, you first need to know that the derivative of tangent x is equal to secant square of x. This fact is extremely useful and you will use it in many integrals. Before we begin the integral of tangent to the power of 5x, I want to show you how the relationship between the derivative of tangent x secant square of x or between tangent x secant square of x can be used. Think that we have an integral as tangent x times secant square of x dx. This tangent x may have any power, it's not important here. What is important here is that the derivative of tangent x is secant square of x. Then if we say that tangent x is equal u, then derivative of tangent x secant square of x times dx will become du. Then this is u and this is du. Then the integral becomes u times du, and the integral of u is 1 over 2 times u squared. And since we set tangent x equal to u, then the integral becomes 1 over 2 times tangent square of x. In all such integrals, if we have tangent x and secant square of x dx, we use this substitution method. Okay, and secondly, you should also know that tangent square of x equals to secant square of x minus 1. This identity is also very important because in integrals involving tangent x, we often use this identity to make a reduction. In other words, to lower the power of tangent x and simplify the integral. Let's see how we simplify the integral. Tangent to the power of 5x, I can write it as tangent cube x times tangent square of x dx. Since we know that tangent square of x is equal to secant square of x minus 1, I can write secant square of x minus 1 instead of tangent square of x. Then the integral becomes integral of tangent cube x times secant square of x minus 1 dx. And let's multiply them one by one. Integral of tangent cube x times secant square of x minus tangent cube x dx times dx. To solve this integral, we will break it down. We split these parts into two, and the integral becomes first integral tangent cube x times secant square of x dx minus the integral of tangent cube x dx. And we will use the same method that we used here to reduce the power of tangent cube x. And we will say that tangent cube x is equal to tangent x times tangent square of x. And now tangent square of x is secant square of x minus 1. Then the integral becomes, let's write it down, minus the integral tangent x times secant square of x minus 1 dx. Okay, let's multiply this by them. Then the integral is, write it, okay, integral of tangent x times secant square of x minus tangent x times dx. To solve the integral, I will split this integral again into two parts. Then the first one is this, and the second integral of tangent x times secant square of x dx, minus becomes plus integral of tangent x dx. For both of these integrals, we will use substitution, and we say that tangent x is u. If tangent x is u, then take the derivative of both sides. Secant square of x dx will become du, and I will use this substitution for both these integrals. Secant square of x dx is du, and secant square of x dx is du, and tangent x is u. Tangent x is u. Then those integral becomes integral of u cube times du minus integral of u times du plus integral of tangent x dx. To integrate this, add 1 to the power u to the power 3 plus 1 3 plus 1, and 3 plus 1 is 4. Then divide by 4, minus u has power 1, and add 1 to the power 1 plus 1 is 2, and divide by 2 plus integral of tangent x. Then this is 1 over 4 u to the power of 4, but tangent x was u. Then tangent to the power of 4x minus 1 over 2 times u square. U was tangent x, so tangent square of x. And let's take the integral of tangent x. To integrate tangent x, I will write it as sine x over cosine x times dx. You know that the derivative of cosine x is minus sine x. Then since sine x times dx is here, I will use again substitution. For this substitution, I will use t. Let's cosine x equals to t, then minus sine x dx is dt. Then this means that sine x times dx is equal to minus dt. Okay, then let's say sine x dx dt minus dt, cosine x is t, then the integral becomes minus integral of 1 over t times dt, and this will be equal to minus ln absolute value of t, and t was cosine x, then the integral is minus ln absolute value of cosine x. Okay, integral of tangent x is minus ln absolute value of cosine x. Okay, this is the integral, but we should add a constant c because the integral was an indefinite integral. So the answer is this. See you in the next video.